Hello and welcome to my first lecture on Chemistry 111. This series of lecture I'm hopeful will be used by the students in preparation for ACT exam, SAT exams in their high school years and also for the freshman chemistry course in college. The lecture can be used in two ways. One is to do a detailed dive in on a particular topic. But if you are reviewing this video as a quick revision a day before your exam, then I would recommend you to just listen and see the last minute or two of the video where I summarize the video once more. So, in general, I'm assuming that the students have read the basic terms in chemistry, including what is chemistry and what are the states of matter, what are the properties of matter, and also they have an idea of what is the scientific way of thinking or scientific model. And so we are skipping all of that and straight jumping into the SI units of measurements. Measurement is essential part of science and of commerce. One needs to do measurements for exchange of goods. One needs to know how much of something that we are selling or buying. Like any other measurements in that we use day-to-day life, for example, you go to a market and buy a dozen of banana. What it implies is you are buying 12 bananas. So dozen is your unit of measurement, and there are 12 units of that. If you say someone's height is 5 feet, we would be implicating that feet is the unit of measurement, and they are 5 times that basic unit of measurement of feet. Or somebody's weight is 100 kilogram, that's again a unit of measurement. We used to have metric system in the past, and then in 1960, of course, a universally accepted system international was developed in France, and that is what is used in the scientific community called SI units. The SI units, as I've shown in the diagram here, come in two flavors. Either you have the fundamental unit or the base unit, or you have the derived unit. So these are the fundamental unit or the derived unit. The derived unit, of course, is a combination of the base units. The base units are 7 of the base units of length, mass, temperature, time, amount of substance, current, and luminous intensity. Length, the base unit is is meter, mass is kilogram, temperature is Kelvin. Important point to make on this is temperature for centigrade is written as degree centigrade, so you have a degree symbol, whereas in case of Kelvin you do not write the zero at the top or the degree symbol. Time is second, amount of substance, especially for small substances like atoms, molecules, and ions, is mole. Current is ampere A, and luminous intensity is cadela CD. Derived unit, as I said, is a combination of base units. Speed, for example, is distance upon time, so meter per second could be one of the units. Density is mass upon volume, so it could be gram per liter or kilogram per ml or whatever unit, but the unit will be that of a mass at the numerator and the unit of the volume at the denominator. Volume itself is a derived unit. For example, volume is length multiplied by breadth multiplied by height, and if you measure all of them in centimeter, it will be centimeter cube. The commonest volume that is used in chemistry is liter, and 1 liter is 1000 ml. 1 ml is 1 cubic centimeter or 1 cc. Often we find that there are quantities that we deal with in chemistry which are either much larger or much smaller than the base unit, and then we have to use exponential form. And I found this mnemonic very useful in describing the exponential, in keeping in mind the exponential form. The great master, King Henry, died by drinking chocolate milk unpasteurized fast. The first alphabet of each of these words would help you to remember what we are talking about. Um, the T here represents tera, G is for giga, M is mega, K is kilo, H is hecto, D is deca, bi is the base, the D in drinking is deci, centi, milli. Unpasteurized, the U is taken as the symbol micro, so this is micro, nano, pico, and femto. All are expressed as the base unit of 10. As far as deci, centi, milli, and micro are concerned, they are smaller units. So it is the base unit is 10 raised to 0. So this will be 10 raised to minus 1. 10 raised to minus 2 is centi. 10 raised to minus 3 is milli. 10 raised to minus 6 is micro. 10 raised to minus 9 is nano. 10 raised to minus 12 is pico, and 10 raised to minus 15 is femto. Similarly, if you're dealing with the higher exponents, then deca is 10 raised to 1, hecto is 10 raised to 2, kilo is 10 raised to 3. You're trying to see how much 1 kilogram is 10 raised to 3 times the base unit, which is the kilo, which is in this case a gram, sorry. The base unit is gram. In that case, 10 raised to 3 kilo would be the exponents which will be equal to the base unit. Then a mega is 6. Giga is 12. I'm sorry, is 9. It goes up by 3. And then tera is 12. Now, I often find students getting confused on the conversion factors. And I found the best way to remind them of conversion factor is to look at the numbers. Look at what your original number is and what you are trying to convert it into a final number. If the original number going to the final number, if the original number is smaller and then it goes to the larger number, then it is always going to be 10 raised to a negative exponent because the original number is smaller. If the original number happened to be larger and then it is becoming a smaller number, then the 10 will be raised to a positive exponent. So original number is smaller, it is 10 raised to a negative power. If the original number is larger, it is 10 raised to a positive power. So, for example, suppose you want to convert 1 microgram to a gram. You know micro is smaller than a gram, so it has to be 10 raised to some power. Of course, what the power number is, micro is 6. Is it plus 6 or minus 6? Which direction you are going is easy to know. If you're dealing with a smaller number as your original number, then the exponent is going to be minus. So it will be minus 6 in this case. Okay. Let's do one more conversion. So now we talk about dimension analysis. So just give you some examples of that. Okay, first example, say I want to give you, and we'll walk you through the sum. Say the speed of light is 3 into 10 raised to 8 meter per second. And we want to convert this into speed in kilometer per hour. So we set up as the speed is 3 into 10 raised to 8 meters in 1 second. So when we set up dimension analysis, we have to be sure that it is set up in such a way that progressively the units gets cancelled and you finally land up with the units that you want. Now I want kilometer here first of all. So I am going to convert this meter into kilometer. And you can either start as 1 kilometer is how much meter or 1 meter is how much kilometer. Doesn't matter which way we go. Let's say we are thinking of 1 meter getting converted to kilometer. As I was explaining, you have to decide, are you going from a smaller number to a larger number or a larger number to a smaller number. When you're talking about converting a meter to a kilometer, you're talking from going from a smaller unit, which is meter, to a larger unit, which is kilometer. So our 10 needs to be raised to a positive to a negative power, because you're going from a smaller unit of meter to a larger unit of kilometer. And you know meter to kilometer is 3. And it has to be a negative power because you're going from a smaller unit to a larger unit. So now we got the meter cancelled off and we have kilometer left. The denominator we want to have it in hours. So 1 hour is how many seconds? So 1 hour we will first go to first let's go to 60 seconds will make 1 minute. So again here seconds and seconds will get cancelled. Now we have kilometer per minute. We don't want that. We want the minute at the top, so that minute and minute will get cancelled, and hour at the bottom. So how many minutes make 1 hour? It's 60 minutes. So now all the units getting cancelled, get kilometer left and hour left. So that's perfectly what we wanted. So answer would be 3 into 10 raised to 8, that's from here, into 10 raised to minus 3 multiplied by 3600, which is 60 into 60. That much we will get it in kilometer per hour. In short, 6 times 3 is 18, 8, 1, 3 times 3 is 9, plus 1, 10. 108, 0, 0 into 10 raised to 5 if you add these two together. And this will land up to be 108 into 10 raised to 7. And if I want to write this in the scientific notation of 1.08, then again I have to think I am going from a bigger number of 108 to a smaller number of 1.08. So I need to write 10, and then I need to say how many places I'm moving. I don't have to worry about whether I'm moving left or right. All I need to care is, am I going from a bigger to smaller or a smaller to bigger? I'm going, in this case, from 108 to 1.08, so it is larger to smaller, so the power of the 10 that I'm going to raise to has to be positive. So now it's 108 to 1.08, so we are moving two places, so it will be raised to 2, plus the 10 raised to 7 is there as it is, that will come back. So answer would be 1.08 into 10 raised to 9 kilometer per hour. Okay, so that's an example of dimension analysis. The other ending pieces I want to talk about is the difference between mass and weight and the temperatures. Now, mass is the amount of matter in any object. That does not change, so that remains unchanged. It doesn't matter whether the object is on Earth, on Moon, anywhere, the mass remains the same. So the amount of matter in an object does not change. Whereas weight is the gravitational force on the object. And the gravitational force, as we know, changes. It will be different at the poles, different at the equator, different on Moon, and different on Earth. For example, on Moon, the gravitational force is 1/6 that of Earth. Therefore, your weight on Moon will be 1/6 that of Earth. So this can change. And the last part to conclude this video would be the conversion of Kelvin is degree centigrade plus 273.15, and conversion of Fahrenheit, which is 9/5 centigrade and degree centigrade plus 32. Okay, so that concludes the first lecture, and I'm going to quick summarize this for people who are looking at this video as a last minute revision. So quick summary of what we said today was, number one is that SI unit are the unit of measurement which is universally accepted. They come in two flavors: the fundamental unit or the base unit, and the derived unit, which are combination of base units. The fundamental units are length, mass, temperature, time, amount of substance, the current and luminous intensity. The mnemonic that we talked about to remember the exponential forms of the various measurements was the great master King Henry died by drinking chocolate milk unpasteurized fast. It basically stands for tera, giga, mega, kilo, hecto, deca, base unit, deci, centi, milli, micro, nano, pico, and femto. The commonest conversion factors you got to remember is milli is 3, micro is 6, nano is 9, and we can always decide whether it is plus 9 or minus 9 or plus 6 or minus is based upon our original number and the final number. If the original number is small, then remember the exponent 10 raised to whatever power will be negative. If the original number is large, then the 10 raised to the power of the 10 will be positive. We did a dimension analysis then, and we concluded difference between mass and weight, mass being the amount of matter and does not change, whereas weight being gravitational force on the object, which can change, and the conversion factors for the Kelvin and Fahrenheit. Okay, so I would then in the next video talk about significant figures, scientific notation, and switching from scientific to exponential, exponential back to scientific, and rounding. So that should conclude the whole first chapter. Okay, see you in the next video. Thank you. Hope you like this.